There's a global health crisis out there that's so massive, it actually rivals malaria in terms of socioeconomic devastation, but it flies almost entirely under the radar. It's called schistosomiasis. And honestly, it's like a microscopic sci-fi thriller playing out right now in the bloodstreams of hundreds of millions of people. Over 240 million people. I mean, just let that sink in for a second. That is the jaw-dropping scale we're dealing with here. 240 million individuals worldwide are currently infected by a parasitic worm that literally burrows through human skin. Absolutely wild. Now, before we dive into exactly how this parasite pulls this off, I should mention that this explainer is brought to you by the research department of the FountainBridge Initiative, helping fulfill their ongoing educational mandate in global public health. Okay, so here's our roadmap for today. We'll start with the invisible global threat, move on to the parasite's bizarre life cycle, contrast intestinal versus urogenital disease, confront the silent burden of FGS, examine floods and One Health, and wrap the whole thing up with treatment and future prevention. Let's get right into it. Section 1. The invisible global threat. So, why exactly does a disease that infects 250 million people stay almost completely hidden from much of the developed world? Well, it really comes down to geography and inequity. While there are definitely cases in parts of South America and Asia, the vast majority of infections and the real crushing burden of this disease are heavily concentrated in sub-Saharan Africa. It's fundamentally a disease of inequity. It primarily afflicts rural communities that have to rely entirely on untreated fresh water just for their daily survival. All right, Section 2. The parasite's bizarre life cycle. Seriously, if you were pitching a sci-fi movie, you wouldn't need to look any further than the schistosoma parasite for your alien. Let's break this down, because it's fascinating. The whole journey kicks off when infected human waste enters freshwater. The eggs hatch into these things called myristidia. And these myristidia basically act like tiny heat-seeking missiles that hijack very specific freshwater snails. Once they're inside the snail, they multiply asexually and eventually erupt. We're talking by the thousands, as free-swimming, fork-tailed larvae called cercaria. And what are these cercaria hunting for? Human skin. So, once those little cercariae find someone wading or washing in the water, they actually burrow right through intact human skin in just a matter of minutes. As they enter, they shed their tails, which is kind of gross but amazing, and become what's known as schistosomalae. From there, they migrate through the bloodstream to the lungs, then the liver, and eventually, they pair up, male and female, and literally mate right inside the human blood vessels. To ground this science in human reality, the first sign of this invasion is usually an itchy, bumpy red rash right where the cercaria penetrated the skin. Then, weeks later, this initial invasion can trigger a massive systemic immune reaction called Katayama fever. We're talking fever, cough, muscle aches, which actually correlates with some pretty intense inflammatory changes in the lungs. Moving right along to Section 3, intestinal versus urogenital disease. Because once these adult worms finally settle down in the veins, that's when the real long-term destruction begins. And the type of damage? Well, that all depends on exactly where the adult worms decide to set up camp. Intestinal disease, which is caused by species like Esmond-Soni and Japonicum, targets the gut and liver simply because the worms live in the blood vessels draining the intestines. On the flip side, we have urogenital disease, primarily caused by Estomatobium. These worms migrate to the blood vessels of the bladder and kidneys. This leads to bloody urine, severe kidney damage, and over time it even drastically increases the risk of squamous cell bladder cancer. But here is the absolutely crucial point to understand. The severe symptoms, they aren't actually caused by the adult worms themselves. Nope. All that cascading damage, the inflammation, the fibrosis, the eventual organ failure, that's all caused by the human body's own intense immune reaction to the thousands of parasite eggs getting permanently trapped in our tissues while they're just trying to exit the body. Which leads us to Section 4, the silent burden of FGS. This is, quite frankly, one of the most devastating and deeply unfair consequences of this entire infection. FGS stands for female genital schistosomiasis. Basically, it's severe gynecological damage caused when those S. hematobium eggs become trapped in the female reproductive tract. And remember how people get infected in the first place? Water contact. In a lot of these endemic regions, it's the women and young girls who are out there doing the daily domestic chores, washing clothes, fetching water from contaminated lakes and rivers.
The sheer tragedy of FGS is compounded by a massive lack of awareness. Women suffering from pelvic pain, bleeding, and painful lesions are routinely misdiagnosed. They're told they have sexually transmitted infections or even cervical cancer. So they suffer in silence. It leads to devastating infertility. And maybe most alarmingly, the microscopic tissue damage caused by FGS drastically increases a woman's vulnerability to contracting life-threatening viruses like HIV and HPV. Now, understanding how tied this disease is to the environment brings us to Section 5, Floods and One Health. We really have to pull back and look at the macro-environmental perspective here. To tackle this, public health experts use something called the One Health approach. It's this collaborative strategy that essentially recognizes a simple truth. We cannot separate human illness from the ecosystems and animals around us. With schistosomiasis, human health is directly, inextricably tied to the health of our waterways and the populations of those specific freshwater snails. Which brings up a pretty vital question. How exactly does a flood trigger a disease outbreak? Well, as climate change alters our aquatic environments and causes more severe flooding, those floodwaters rapidly spread the intermediate snail hosts and the infested water into entirely new geographic areas. Suddenly, human populations who might have been perfectly safe before are completely exposed. So how do we fight back? Let's move to our final section, Section 6, Treatment and Future Prevention. It's a massive challenge, for sure, but we do have some highly effective tools at our disposal. Our defense strategy is basically twofold. On the medical side, the frontline treatment is a drug called praziquantel, or PZQ. And what's really fantastic is that we now have pediatric formulations, so we can safely treat preschool and school-aged children. But medicine alone just isn't enough. Preventative measures are absolutely critical. We're talking WASH, water, sanitation, and hygiene. Giving communities access to safe drinking and washing water literally stops the cycle in its tracks. Combine that with snail control and community education, and we actually have a tangible path forward. Looking closer at the medical side of things, praziquantel is the absolute gold standard, the primary treatment across all major schistosomal species. Just a single day of this oral medication is incredibly effective. It basically causes rapid, paralyzing muscle spasms, or tetanic contractions, in the adult worms. That allows the human immune system to sweep in and clear them out safely, completely stopping the daily release of those highly destructive eggs. So we know about the alien-like life cycle. We know the immense human cost, especially to vulnerable women and children, and we have an effective drug. But solving this crisis, it isn't just about medicine. It's inextricably linked to providing humans with our most basic fundamental right, clean, safe water. Thank you for joining me on this explainer. I hope it leaves you wanting to dive even deeper into the invisible ecosystems that shape global health, because it really leaves us with this final provocative thought. Can we ever truly eliminate a disease that relies on the very water we need to survive?